Hi, this is a video that will review some of the topics from Chapter 1. I read through some of the feedback that people posted in their progress checks, and they just wanted to go through each of the chapters, look at some of the vocabulary words, and that's what we're going to do. We're just going to look at some vocabulary words, learning targets from Chapter 1, and maybe a few examples. So in Chapter 1, the first three learning targets that we talked about were identifying individuals, so who or what is the data about, and the variables, so what are we looking at each variable? What characteristics? So for example, individuals could be a person and the variable could be eye color. The second learning target is identify categorical versus quantitative. Hair color or eye color would be categorical, quantitative would be a variable like age. And then the third learning target, and a lot of people ask this question, is describe the distribution of the set of data. And the distribution is describing all of the variables and all of the values that those variables come about. And so if it's just categorical, well then you're just talking about the categories and what are the outcomes in each category. So what are the types of eye colors that you could have. If it's quantitative, we looked more into that in a few of the other sections. That's looking at what's the center of your data, what's the spread or standard deviation of your data, what are the outliers if there are any of your data, and what's the shape of your data. Is it symmetrical? Is it bimodal? Is it uniformed, etc. But in the first part of this chapter, we just went through and identified individuals, variables. Distribution is all of the values that those variables had. And then inference is that idea of being able to draw conclusions about your set of data from our sample of data and drawing conclusions a little bit more about the population of the data. So those are the first sort of three learning targets, and we'll get into distribution a little bit more. So again, examples of those first three learning targets: who are the individuals? If you read through this, Mr. Buckley gathered some information on his class. So the individuals are the students in the class. What are the variables being measured? Gender, ACT score, favorite subject, grade point average. Identify them as quantitative, categorical. Describe the distribution. So question 3 is the one that a lot of people have asked, describing, okay, you want to do distribution of ACT score. You first might want to find the center. So you're going to add up all 6 of the students' scores and find that mean. That's one measure of center. If there happens to be an outlier, if 28 is really far off, or if 35 is an outlier, you describe those outliers. If there is an outlier, then maybe you'd want to describe your center by the median instead. So we have our center, we have some outlier options, we have then describe your spread. So what's the standard deviation? We can use that calculation. You can also use range, which is a very basic measure of spread, like how far is it from 28 to 35. You can also use the interquartile range. How far is it from quartile 1 to quartile 3? And then the shape. Is it symmetrical? Is it skewed? Etc. And then question 4 is that idea of inference. And I'll come back to both of those and give you the exact answers that like the book would want to see. But question 4 is, could we infer from this data set that the students who prefer math and science perform better on the ACT? So can we draw a cause and effect based on this relationship? And so we don't necessarily have enough data for that. So let me just read you the exact solutions for those 2 questions. Again, this is from Chapter 1. So in the way that they would read it from the textbook, they would talk about, again, the distribution. The ACT scores range from 28 to 35, with a center around 32. 4 of the scores are bunched up in the 32 to 35 range, while Jonathan's score of a 28 does not quite fit the rest of the scores. So the reason they describe it, excuse me for my screen, the reason they describe it that way is because we hadn't technically learned about all those other pieces yet in Chapter 1. And then in terms of the 4th question, we cannot infer that a large difference between the scores of these students and those who do not perform on the math and science pieces. So we don't have enough evidence to say that they are any different. Okay, so those are kind of the first few pieces of Chapter 1. The next vocabulary words and learning targets are I can display categorical data with pie charts or bar graphs. Remember, bar graphs have spaces between the categories. I can distinguish between good and bad graphs, so things that are being labeled, making sure that there's, again, they're not using pictograms, they're using bars so that we don't look at them differently, making sure they start their scale potentially at 0 for bar graphs. Learning target number 3, I can construct and interpret a two-way table for categorical data. So that's exactly what we just looked at in the last example. Two-way data would be one category, for example, ACT scores and GPA, or student and GPA, etc. And then I can describe the relationship between two categorical variables using marginal conditional distributions. Marginal distributions would be what is the total for a column or a row, total number of people, or relative frequencies is what percentage fall on that row or column. Conditional is when you look at a single cell of a data point, and we'll look at an example next. For example, what percentage of males wear red? That would be a conditional versus what percentage of people are male in our group or students in our group. And then you can see that these are the vocabulary words. Frequency table, just how many people do or how many individuals have that category. Relative frequency, anytime you see the word relative, that's a percentage. Pie chart, bar graph, two-way table is just a table, and we were just mentioning marginal and conditional distribution. And the last vocabulary word is association, and that was our positive association, a negative association. When you're looking sort of at a graph, are they even just related? Is there any relationship between those two variables? So let's just look at an example next. So here's an example of can I describe the relationship between two categorical variables. We have coffee preference by gender, and then we have sort of, this is the preference way of the table, and this is the gender, so that's why they call it a two-way table. When you put the totals, those are considered marginal distributions or marginal frequencies. And then if you start to calculate, I'm going to just kind of go through, if you start to calculate conditional distributions would be what's the probability that you like, that you're male, given you're in the national chain row. And so that would be like, oh, there's 95 males out of the 160 who like national chain. And then you could find that probability. That's conditional. Again, if you look at your formula sheet, that would be the probability of male and national chain divided by national chain. And we actually started doing this back in Chapter 1, even though we officially came up with this formula in Chapter 5. Likewise, if you wanted to know what's the probability that you like national chain coffee, given you're looking at all of the males, you still want to know, okay, national chain and males, but now you're going to divide by the total number of males. So it's still going to be 95 on the top, but instead you're going to divide by the 535. That's what they refer to as conditional probabilities, conditional relative frequencies. And when they ask this question, what can we conclude about the association between gender and coffee, you would maybe look at, again, out of all the gender, what percentage of males like each of these? Out of all the females, what percentage of females like all of these? And then you can compare. If those distributions are the same, well, then we'd say there's really no association between their preference. It doesn't matter if you're male or female, you like coffee the same way. If you see a difference, well, then there's some sort of association. So you could look at all of that. If I was going to compare two distributions, the male and the female, I might do side-by-side bar graphs to say, oh, what percentage like national chain, what percentage like one mean bean, and you could do side-by-side bar graphs. You also can do those segmented or mosaic, what they call mosaic bar graphs. That's where you stack their totals on top of each other. So you could say, you know, this percentage of males, and have like your bottom part of your graph shaded one way is the national chain, and then stacked on top of it would be the percent who like the one mean bean, and you keep stacking up until you get to 100% for that segmented or mosaic bar graph. So that's kind of what we did in the middle part of chapter 1. After we looked at categorical data, that's what we were just kind of looking at in a two-way table, we then looked at a whole bunch of ways to display quantitative data. So you could make your dot plots or your stem plots. And then when you make those, that's for small amounts of data. You could also construct and interpret a histogram, and you'd make a histogram if you have large amounts of data. And again, a histogram is where you have a range of numbers and how many fit in that range of numbers. Histograms do not have spaces because they're numbers, and that can include potentially decimals, and there's no gaps between, even if you're counting whole number things, there's no gap between one mouse and two mice. So your histograms butt up to each other. You just have to make sure that your widths are exactly the same size. Again, and this is where we start to talk about the shape. Some of the things that we can list as shape are skewed to the right, skewed to the left. Unimodal just means one peak. Bimodal means two peaks. You can talk about it having a gap or a space between them. We have our center. Centers, we again mentioned mean and median. And then we talked about spread. Spread is how much is your data just away from the center, how much is it spread out. We can talk about standard deviations, variance, and then we learned our outlier rules. So that's kind of the middle part of the data, and then that last piece was, the last section of chapter 1 was just really being specific about those measures. So again, the last learning targets again are being able to calculate the mean and the median, being able to find the range, find your quartiles and that interquartile range. That 5-number summary is your minimum, your quartile 1, your median, your quartile 3, and your max. Then we talked about how when you have that 5-number summary, you can display that as a box plot. And in chapter 1, that's when we first talked about the equation and the calculation for standard deviation. Standard deviation is on average, how much do your values deviate from the mean? And it's a measure again of spread, as how large is that deviation. And then variance is if you take your standard deviation value and you have squared it. So they're both measures of spread, and variance is just squaring your standard deviation. And then the last thing that we learned about in chapter 1 is that interquartile rule, the 1.5 IQR rule. And so these characteristics that we're talking about here are all the things that you're going to be kind of asked to practice on that first chapter 1 relearn worksheet. So you're going to go through these pieces. All the learning targets that I've listed here are also listed in your textbook. If you look at your chapter summary, they'll have them listed, and then they'll give you a review problems to look at, examples in the text to look at if there's any learning target that you are confused about. But I wanted to give you the vocabulary terms for chapter 1. If you have questions, please email.